All right, so welcome back to Module 5, where we'll be discussing version control, and that's with Git and GitHub. Now, this is so important for anyone that is going to be a developer, right? So, you're going to understand how professional developers manage their code, track changes, collaborate, and prevent loss. This is the foundation of modern software development workflow, right? Now, why does version control matter? Code constantly changes in real projects. Bugs and updates are inevitable. Multiple developers work simultaneously on a particular project, right? Without version control, there will be chaos, loss, and no traceability. Version control provides safety and structure. Now, what is version control? All right, it's a system that tracks code changes over time, stores multiple versions of your project, allows rollback to previous state, acts like say act like save history and undo for code, right? So it basically backs up your code and helps you manage your code to different versions, right? So if any particular version is no longer functional, you can always revert back to a version that is functional. I can't tell you enough how important this is for every developer. So let's see a real life analogy. So in the first version, there's a first draft. In the second version, there's an edited version, right? And then in version 3, there may be a final output. So you have the ability to return to any version at any time. That's one of the advantages it gives you. So same concept applies to your code management. So introducing Git. Git is the most widely used version control tool. Tracks files changes efficiently, saves versions as commit, right? Operates locally on your system. So key Git concept: repository, which means your project folder. Commit means a saved snapshot of your code. That means a portion of your code for this particular version being sent to that particular folder, which is the repository, or we call it repo in short. Stage means preparing files before commit. So you prepare these particular files by categorizing them, grouping them, and then getting them ready to be committed, right? Um, Branch means an independent version of a project. And these are good concepts we will see when we come to the actual practical class. All right, so here's the Git workflow. Make changes to code, state changes using Git add, commit changes using Git commit, repeat process continuously, and build a full history of development. Now here are basic Git commands. Git init, which is I hope I'm pronouncing this right anyway. It should probably is Git init, but I like calling it Git, so you get to work with that. Git init, which initialize repository. That means you get to initiate it in the first place. To set it up for your project, you use Git init. Then you can use Git add, which is to stage all of the changes. So it collects all of the changes and adds them for staging, right? Then Git commits those changes. Usually comes with a remark. You have to put a remark to identify that particular comment, right? And then Git status, which checks the project state, all right, to know what have been changed so far, all right. Then these are essential daily commands we use with Git. So now we have GitHub. Now note, I focus this on GitHub because it's the most popular Git platform, all right, that we use. But there's also GitLab, um the other version control platforms. But the most popular I know is GitHub and then GitLab. All right, so GitHub is a cloud-based platform for hosting code. It store repositories online, enables collaboration across teams, acts as backup and sharing system. Now, GitHub has also begun AI coding too, which is the Copilot. All right, Copilot. In fact, two platforms for AI coding, which is Copilot and Codespaces. Both of them are functional and amazing, right? Um, so Git versus GitHub. All right, let's get to understand what that means. Git means local version control tool, while GitHub is the online hosting platform. Usually, if you're going to use Git, you have to install Git as an app on your device for it to be able to initialize properly. All right, so Git manages the changes, GitHub stores and shares the code. So together, they create a full workflow. So connecting Git to GitHub. So you can create a repository on GitHub, link the local repo. So from the local folder in your device, it links it to the online one and backs it up. Now the advantage of backing up your code is that I can work independent of my system at any time. Anytime my system crashes, I don't lose anything. I can recover all of the apps I've been building, right, easily. So it takes you from your local repo to the online, or we'll call it remote repo, right? So you can push code using Git push and then synchronize your local and online versions. All right. So there's also another concept that we didn't mention, which is Git diff. Git diff is when it checks whether the online version, there seems to be a difference between the online version and the local repo, and then it can merge all of them together. All right. So why GitHub is powerful, secures backup of projects, access code from anywhere, and then also okay, share your work easily, build public developer portfolio, and then you can also use it to host. You can, like, basically most hosting platforms will require your GitHub, all right, integrated, all right, on the platform for it just to be able to deploy it on that hosting platform, right? So it's very, very important. So collaboration with GitHub, multiple developers can work together on a project. So all of them are sending their commits to a particular repo, right? They can track contributions clearly, review code before merging it. So they have a main branch. So each of them can push to a particular branch, review what the impact will be like before merging into a particular um, a main branch. I mean, manage updates systematically. They can also produce industry standard teamwork model. All right. So branching means creating separate development paths. All right. So you create separate development path, and maybe because you don't want you're concerned about certain changes you're making in this commit that could affect the entire project. So you just put in a different branch on and checks it out. If it works out well and there are no problems, you can now merge the code all together, right? That's what branching does. So you can work on features independently, fix bug without affecting the main code. It's like more like a safe safety measure. You're trying to check your code within a sandbox system. That's just how it is in branching. All right. So feature development example. So we can say a main branch remains stable. You create a new branch for a feature, develop and test the feature, merge it back into the main branch, prevent system breakage. Common beginner mistakes: not committing changes regularly. Man, if this ever happens to you, you so angry because you have lost a lot of lines of codes, right? Forgetting to push updates, working directly on main branch, or ignoring messages. Best practices: commit small changes frequently, write clear commit messages, use branches for new features, push updates regularly, maintain clean workflow. So here's a real world workflow where you can clone a repository. That actually means to have a copy of that repository. You can either copy it out and put it in that project, or you can download that repo. All right. You can create feature branch, develop and test code, commit changes, push to GitHub, merge into a main branch. Mini practical exercise: install Git on your system, create a project folder, run git init, git add with a dot. So when you do git add, you give a space and a dot afterwards, then git commit. Like I said, git commit will usually come with a remark or like a comment you put to describe what you're committing. Then you're going to also have to create a GitHub account, push project online. Now, all of this will have better appreciation for you when we get to the practicals, and that will be so lovely. I'm so excited to show you all of this and how you can be doing this with AI. You don't have to rack your head about it, but it's good for you to have a foundational knowledge on these things. Now, here are the key takeaways. Version control protects your code. Git manages your changes locally. GitHub enables cloud collaboration. It's essential for your teamwork, and scaling is a must-have for developers. All right. Next module, we're going to be seeing AI assisted development. We're going to learn how to code faster with AI tools, combine programming with AI efficiency. I mean, we are getting into the real stuff. All right. See you in the next class. I'm sure you'll be excited.